Welcome back to another math video. We're talking about the surface area of pyramids, cones, and spheres. We may put cones and spheres on a different video, but we'll see how far we get to in this video today. In general, the surface area is the amount of space that covers an entire object, so we're going to have to add up all of the surfaces on this object and figure out what total surface is being presented to us. It's always important that we have a formula, a substitute, and an answer. So we got to have all three of those steps for us. Let's try this out. Calculate the surface area for each pyramid below. Let's try the first pyramid. So what is a pyramid? A pyramid is a square base usually, or a rectangular base, and then it's going to have four triangles on the sides. Now the four triangles may or may not be the same size. They may not be the same size triangle. They will be the same if the base of the pyramid is a square. So let's see how the base here of this triangle right here, it's got a base of 8 centimeters, and this triangle here also has a base of 8 centimeters. So it's going to be the same triangle. We only have to calculate one triangle and then multiply it 4 times, because there's one at the front, there's one at the back, there's one on the right side, and one on the left side. So the surface area of a pyramid is going to be the area of the base, plus it's going to be area of the triangle. So let's try this out. The surface area of this pyramid is going to be the area of the base. So that's just length squared. That's 8 times 8 centimeters. And then we have 4 times the area of a triangle. The area of a triangle is base times the height of the triangle. So the base is 8 centimeters. The height of this triangle. The height of the triangle always connects the tip of this pyramid, or the vertex of this pyramid, all the way down to the midpoint of this base here. And that's what we call the slant height of this pyramid. So the height of this triangle is actually the slant height of the pyramid. It's 7 centimeters divided by 2. Perfect. So 8 times 8 is 64, plus 4 divided by 2 is 2. 8 times 7 is 56. 56 times 2 is 112. So the surface area of this pyramid is going to be 64 plus 112 is 176 square centimeters. Now, the most difficult part of this problem was identifying that the slant height over here, that's the height of our triangle, and we call it S. That's the slant height. The base of this triangle is whatever the base of our pyramid is. Let's try another one. So here we have another pyramid, but hopefully you can recognize that this is not a square base pyramid. This pyramid has one length for one part of the base and another length for the other part of the base. So it's 16 by 12. So we can't say that this is the area of the base plus 4 triangles, because the triangles aren't the same. They don't have the same slant height, as you can see, and they don't have the same base. So the surface area of this pyramid, is going to be the area of the base plus 2 area 1, so triangle 1. So we'll call this one triangle 1, and then we'll call this one triangle 2. And then there's 2 area 2s. So there's a right side and a left side. They're identical. There's a front side and a back side to this pyramid. They are also identical. So the surface area of this pyramid is the area of the base. Well, the base is 12 by 16. There's two area 1s, so that's 12 by 11.3. 12 by 11.3 divided by 2. And then there's two area 2s, and that's 10, the slant height of 10, and 16 across the bottom. So 10 by 16 divided by 2. Now hopefully you can see that the 2 and the 2 here cancel, the 2 and the 2 here cancel. It doesn't really matter if you were to just put it into your calculator. Your calculator could do the work for you anyways. So let's calculate this up. 12 times 16 is 192. 12 times 11.3 is 135.6. And 10 times 16 is 160. When I add all of this up, I get 487.6 square centimeters. So that is the area of this pyramid. Again, the hardest part about this is recognizing that we've got one triangle front and back like this, and then we've got another triangle side to side like this. So we've got one area over here and again on the other side, and we've got one area over here and again on the back side as well. Here's a little bit of a curveball for us. It's saying calculate the surface of the square pyramid below. So it's square base pyramid. It's 4 millimeters across the bottom here. If it's a square base pyramid, that means it's also 4 millimeters across there. But there, I don't know if you can tell, they're giving us the height, but they're not giving us the slant height of the pyramid. So we want the distance from here to here. We want that distance. We don't want the vertical distance of the pyramid. Let me redraw this from this perspective. So we've got our pyramid, and we've got a height of 2.1 millimeters. We've got a base all the way across of 4 millimeters. And what we want is we want this slant height. We're curious, how can we get the slant height? Well, if we kind of just focus on this part of this triangle, sorry, that's not really helpful, is it? If we just focus on this part of the triangle here, so the one side is 2.1 millimeters. This is a 90-degree angle. What's this side of the triangle? Well, that's half of the distance across. So this is 2.0 millimeters. And this is the slant height. That's the hypotenuse of a right angle triangle. Well, I know how to get the hypotenuse of a right angle triangle. S squared equals 2.0 squared plus 2.1 squared. Okay, well, if I calculate this out, 2 squared plus 2.1 squared is 8.41 square millimeters. And so if I take the square root of that, I will get a slant height of 2.9 millimeters. Perfect. So we actually know that our slant height is 2.9 millimeters. Now we can go ahead and do the surface area of our pyramid. Surface area of our pyramid is going to be the area of the base plus, because it's square based, all the triangles are the same. So 4 times the area of the triangle. Area of the base is just 4 squared. The 4 times the area of the triangles. Each triangle is 4. It's 4 across for the base. And it's 2.9 for a slant height divided by 2. So if we calculate this out, we're going to get a surface area of 39.2 square millimeters. Perfect. Again, the key here was identifying that slant height, the slant height is the hypotenuse of kind of this side perspective, right? If we were looking at it from the front of the page here, kind of looking in at the pyramid, this is what we would see. And so being able to identify that slant height is really important. And the last example that we're going to do right now is the surface area of this square pyramid. The surface area of this square pyramid is 96 square centimeters. Calculate the slant height. Okay. Well, this is a square base pyramid, so I know that the surface area of this pyramid is the area of the base plus 4 times the area of the triangle. Well, let's just kind of write this out a little bit more. The surface area, the area of the base is the base squared. 4 times the area of a triangle, so 4 times the base times the height. So that should be slant height, right? Divided by 2. If we try and find the slant height, what we can do is we can put in all of our information if we want to, and then try and solve for slant height, or we can rearrange right now. And if we rearrange right now, then it might be a little bit easier. Doesn't really matter to me. What I'm going to do is I'm going to put all the information in, and then I'm going to try to find the slant height. So if the surface area is 96 square centimeters, the base squared is going to be 6 times 6 is 36, plus 4 divided by 2 is 2, the base is 6, and then s. So 96 is 36 plus 12s. That's a little bit easier now. How do I solve for s? And I'm going to subtract 36 from both sides, so I get 60 equals 12s. And if I divide by 12, I get s equals 5. So the slant height is 5 centimeters. Perfect.